Welcome to Education Online program. With you is teacher Willa, Lucia. So today we are going to be learning about forces. Okay. We shall be having our topic as forces. How would you define the force? Let's look at this example. You're driving a car, then the car gets stuck in mud. What happens? What will you do? You want your car to move. You cannot leave it there. Then you're going to have options. It's either you will get another car to pull it by tying a rope to it, or you're going to have people to push it. So when you're giving it that push or the pull, you see that there is serious application of force there. So that means that if you want to define force, we can say a force is a pull or push that changes a body's state of rest or motion in a straight line. That means that when you pushed this car, it did not stop, but it started moving. But then before it getting stuck, what happened? It was fast moving because you were driving. So there is a force that was applied onto it that made it stop. So when you push it or pull it, that means it is going to start moving. So we say that any force, when you apply force onto something, if it was moving, it can either change the speed, or it comes to rest. Or when it is already moving, it can, or when it is still at rest, you can give it a push or a pull and then it starts moving. So we say that our force is a pull or push that changes a body's state of rest or motion in a straight line. Why is it in a straight line? Because forces always act in a straight line. That's why we have it there, the straight line. So these forces come up in different types, but there are majorly two types of forces, and the rest are all they are all grouped under those two. So what are these examples? Let's have it here as examples. Oh, instead of example, we rather put it as types of forces. Types of forces. Since we say there are majorly two types, what are those? We have one which is known as the contact force, and then we have another one which is known as the non-contact force. So we have the contact. We're having it here as our contact force as the first type of force. So we have another one which is the non-contact. But we are going to start, we shall look at these types one by one, and we see what other forces have been grouped under a specific or a particular type of force. So let us start with the contact force. We have it as our contact. How can you define that? Because before you go into grouping the forces under them, you will need to know the definition. Because if you know the definition, then you know the type of, or you know what happens with a certain force. When you apply certain force to any object, then you're in position to group it in the right place. So we have our contact force as we can say that these are forces that are due to interaction between two objects. So let me put it down so that we don't forget it. We have it as these are forces that are due to interaction. Due to interaction between two objects. So we have it there. I think this is not very clear. Let us write it from here. Between two objects. Meaning that if you want to develop this contact force, these objects you're having, maybe the two objects have to be in contact with each other. They should be touching one another like this. So this means that this one, they are in direct contact with each other because there is no space between them. So what are the examples of these contact forces? We can have the first example as so here we have the examples of contact. If we say that we want them to interact, what could be their example now? That is more like the grouping of these forces. We have the first one, which is the applied force. That is one of the examples of contact forces, applied force. How do we get this applied force? Let's look at this. You've gone to the borehole, you have a jerrycan of water. The jerrycan of water is a bit heavy. You want to lift it and put it onto your head. What will you do? What are you going to use? You're going to use your hands and try lifting it up onto your head. That means that you've used your muscles. Meaning that with this applied force, it is when you use your muscles and apply the force to lift something, it gives rise to this type of force. And sometimes it is known as the muscular force. This muscular comes from the word muscles, because there you've used your muscles. So we have another type of force, which is the normal force. How do we get this normal force? So this normal force here is exerted by a surface onto an object. What surface are we talking about? It can be any surface. Let's take example of a table. You have a table and then you have a cup. You've placed the cup on the table. So this table here, the in front where you've placed the cup, becomes the surface of that table. So what happens is that this table is going to be exerting a force on the cup. It doesn't mean that when I have my hands and I put this tissue paper on it, it is only this paper exerting weight on my palm. No, even my palm is acting or is exerting its force on the tissue paper. So the force this palm here is exerting on the tissue paper becomes the normal force. Just like the table will be exerting a force on the cup, and then that force it is exerting is what is known as the normal force. It acts perpendicularly onto that object. So you see that when this object is at rest, that means that the force, the table, the surface is going to exert on that object becomes equivalent or equal to the weight that object is exerting on the surface. That means that normal is equal to the weight of the object. That is in a condition that the object is at rest. Because if it is in motion, that means that there are other forces also acting on it, which makes it not be equivalent or equal to the normal or to the weight of the object or the surface. So we have another force which is known as the tension force. The tension force there. From the word tension, you'll see that there is a serious pull that acts on it. So with this tension force here, it is a force that is being transmitted through a string, or you can say a cable, or it can be a wire that is pulled tightly by another object which is tied in the opposite end of that string or cable or wire. Let's look at an example of this. We are creating our own string here. We are assuming this is a string. So we are saying, because we said it is a force that is transmitted through a string due to a tight pull by an object that is held at the other end. So this becomes our string. Let's look at an object. We are going to tie this right here to act as the object that is giving it a pull, giving the string a pull. So there we have it. Oh, okay. I hope that works. So assuming here, up here, we are going to hold it like that. We are hanging it right here. This marker pen here has a weight. So it is pulling this string downwards. So what happens is that this string here is going to have another force that is being transmitted through it. And this force here is what is known as the tension force. And it acts just perpendicular and straight on to the rope or the string. So our tension will be acting in the opposite direction. Meaning if this is our string, and then this is a weight, we are tying it to the one end, and then like that. So this one is acting down, pulling it with its weight. So if it is its weight, this tension force here is going to be acting in the opposite direction to this object here. So here will be our tension force. So that is how we get the tensional force. So this takes us to another type of contact force that is known as the air resistance force. Okay, we have it as our air resistance force. From the word resistance, if you know the meaning of this resistance, it becomes very cheap for you to define air resistance force, because this term resistance means the opposition. Okay, the opposition something will offer. So we can define our air resistance force as the opposition offered by air to any object that is passing through space. And this is because when you have air is made out of tiny particles, and these tiny particles are not bonded together. They have a very weak intermolecular bonding forces amongst them. So meaning that these particles move from one point to another randomly. So when they come onto another surface, when they come into contact with any other surface, if the surface is in motion, it is going to slow down the velocity or the speed with which the object is moving. That's why we are saying it is the opposition offered by air, because of what they will do to any object that is passing through air. That's why we say that that's why we see a plane. If you have a plane, look at how it is being constructed. It is modified in such a way that the tip here is very small. What if it was like this? What will happen? You see, if the in front part is like this, look at that. Those are two different shapes there. You'll see that because this air resistance, or it depends on the area, the surface, well, the surface of the object. That means that if the surface is big, there will be more of these molecules coming right here and coming into contact with this surface. There will be very many. So meaning that if you're supposed to pass through air and you have this, your speed will automatically be reduced. So that's why you see that a plane has this shape, because there you've reduced the surface area of the plane, meaning that very few molecules or particles of air will come and attach itself onto that, and this will cause the plane to continue with its speed without it being slowed down. So we still have another example. There are very many in real life. So we can also call this air resistance as the drag force. Those two are still the same. So we're going to the next example. Let's look at friction force. Friction force. With frictional force, we say that it is a force that opposes motion of a body. So when this body is in contact with another, what happens? Let's take this. Okay, let's take example of myself walking. What happens is that you see the surface, I'll be stepping on. If it is slippery, what happens is that I will easily fall. But then the surface is a bit rough. That means that the molecules, the particles of my leg is in position to attach itself onto the other particle of the surface I'm stepping on. So creating that kind of frictional force. Because if there is no frictional force, it is going to be hard for me to walk. I'll be easily falling down. So we say that it opposes the motion. It will slow you down, yes, and it also has its own advantages. So these are some of the examples of contact forces. They are not only limited to that. There are still more variety that you can list under that. So let's now look at the non-contact force. Non-contact. If we say that with a contact force, if we say that it is due to interaction between two objects, what will be this non-contact? That means it is the opposite of the contact force. With a non-contact force, the two objects do not come into contact physically. So we can say that a non-contact force is a force that do not involve a physical interaction or physical contact between two objects. So if they don't, what happens? That means that they act through space. If I have this and this, and I don't put them together, but still they feel a force in between them, that means that this force here is being transmitted or acts through space here. So if it is through space, what do you think could be the examples of this kind of forces? We can have one which is the electric force. The electric force. This electric force here, we can say that it is a force that is in all charged bodies. If it is a force that is in all charged bodies, what are these charged bodies? Charged bodies have others carry positive charges and others are negatively charged, because what the interaction this charged body will be having in between its ions is that brings about the electric force. Even though it is just the negative, it will still have the electric force acting in it. So this electric force here, because due to the presence of these charges here, it will give rise to other types of other examples of these non-contact forces, because charges do not only they are not only on rest, but then others are in motion. So if they are at rest, that means that they give rise to another example which is known as the electrostatic force. So we have it here as electrostatic. We have it as our electrostatic force. So this electrostatic force here is due to these charges that are at rest. So you see that when you have charged bodies, and the charges in that body do not move from one point to another, they just interact in between them, they will have, that means that they are pulling each other using this what is known as the electrostatic forces. It can either be an attraction force or it can be a repulsive kind of force. So we also have what is known as the magnetic. That comes as magnetic force. You see that this magnetic force here comes as a result of these charged forces being in motion. So when these charged bodies are moving from one point to another, they will create a magnetic field. And where there is magnetic field, that means we have a magnetic force acting in that area. So for instance, I have this let me take this too. They are carrying charges into them. So let us see these objects. What type of charges? You see that when I'm trying to bring them together, they have already created a field around themselves. So this field here, you see, I'm feeling the force as I'm bringing them together. You see, they are failing to come together. Why? Because they are carrying charges that are similar. And these charges here, okay, they are carrying similar charges. That means that they are having a repulsive force in between them. That's why I'm saying that a magnetic force can either be also attractive or it can be repulsive. So you see these three here, they almost sound alike. Because if you talk of the electric force, we are saying it is the force that is in all charged bodies. What of the electrostatic force? It is almost similar to the electric force. But the difference is that for it exists, it is the force due to these charged bodies being in stationary, I mean, because in motion is the magnetic. This one is is at station, but this one here is in motion when the charges are moving from one place to another. So we have still another example of this non-contact force, which is known as the gravity force. We can say the gravity force, or we can even say that it is the force of gravity. It is still a correct thing. So this gravity force here is equivalent, is equal to the weight of the object. So we can say that we can define this gravity force as the weight of an object. And this gravity force here is mostly experienced by massively large bodies. Which bodies are we talking about? There are large bodies like the Earth. We have other bodies like the Moon. You see, these bodies are really very big. They are big in mass. So meaning that they have this force that is trying to pull objects that are surrounding them on top of them into the center. That means the gravitational force, the gravity force, acts towards the center. So you'll look that if this is our Earth, since we said it is spherical, there are objects just around the surface of the Earth, all around. Why is it that these objects do not fall apart? Because there is this force we are talking about, the gravity force, that is pulling these objects towards the center of the Earth. We can see that this object here is not in direct contact with the center, but still they have a force that is trying to connect them together. So this is the gravitational force of attraction. So we say that this gravitational force here is equivalent to the weight of that object. For instance, if you jump up, you still come down. That means that the force that is pulling you down, not allowing you to just hang in space, is the gravitational force, and it is equal to your weight. It is not smaller than your weight, or your weight is maybe greater than that force. That's why you still come back into the direct, pulling yourself to the center of the Earth. So we can see that today we've learned a lot about forces. We have the definition of the force, where we said it's the pull or the push that changes the body's state of rest or motion. That means that anytime you apply force on something, it might change its state of rest. How does it change the state of rest? It can change its position, of course. It can either start moving or just move away from that same point. It will go to another point. So we have seen the types of forces. So we say the contact force and the non-contact forces. So under these contact forces we have variety, because obviously when you look at these examples of these contact forces, we'll see that there is a direct kind of contact in between the two objects that are experiencing the force. You can see the normal force where the table has to be, and then the cup is on the table. That means there is a direct contact. When you look at air resistance, the particles of air has to come into contact with the surface of the object. That means that those with contact forces, those two have to come into serious interaction, direct interaction, which is a different case with the non-contact forces. With these non-contact forces, for it acts through space. You don't have to bring them much together, attaching themselves direct to experience this force. But even though it is in a distance like this, it will still have, just like the example I've shown you there of the Earth and the objects on its surface. The objects don't fall apart even though they are not in the center of the Earth, because this force here is trying to keep them together, attracting each other. So we this today we shall come to the end of our lesson, but we shall still learn more about some other types of forces in our next lesson. So we shouldn't say that these are the only examples. There are also others you can find out, like we can talk about the spring force. So those are still other types. So we are ending here for today. We shall meet again in our next lesson to learn more about types of forces. Bye bye.